I'm David Tarazzi, and we're going to be discussing, as Alex said, checkpoint inhibitors. So as we all know, the immune system is very powerful. A saying that I'm sure all of you have heard is, with great power comes great responsibility. The immune system is no exception to that saying. Because of this power, it needs a way to keep balance, or a way to make sure that the immune system doesn't spiral off and destroy too many cells, which will destroy healthy tissue and organs. Checkpoints are the immune system's balancer. They are molecules on immune cells, particularly T cells, that prevent them from overactivating. In the case of cancer, however, we want as much immune cell activation as possible. We want a way to block these checkpoints so that immune cells are able to reach their maximum potential. Checkpoint inhibitors are the drugs that are able to block these checkpoints and unleash a powerful immune system with nothing in its path that can stop it. So Kailey's going to go over the animation.
So I know you guys have been sitting for a little while, so I'm going to talk about this pretty briefly. Checkpoint inhibitors are really interesting in immunotherapy, and like Alex has said, they have a really high success rate compared to other immunotherapies. So without further ado, here is our video. So for checkpoint inhibitors, so before explaining checkpoint inhibitors, it's important to understand that checkpoints are not the same as checkpoint inhibitors. So I think David explained that checkpoints are essentially a way to keep the T cells from killing all the cells around it. So therefore, checkpoint inhibitors allow the cell to continue to kill things. And that's really important with cancer because you need your T cells to continue to be activated so that they can really kill the cancer cells. So here we go. And then, yeah, so we have basically, okay. So normally T cells attack foreign cells when they encounter them. However, this activation leads to the buildup of immune cells, which can cause inflammation. And in large amounts, this inflammation can become harmful to the body, and additionally, this overreaction can create mutations in autoimmune disease. So to combat this, T cells have receptors which help to moderate the activity and prevent this inflammation with the use of checkpoints. So checkpoints are basically drugs that are administered to stop, or checkpoint inhibitors are basically drugs that are administered to stop these checkpoints. So here we have two receptors. The first acts like a gas pedal in a car. I'm sure you guys have all driven a car and you know that the gas pedal will help to accelerate the T cell and accelerate the car and let the car move. So similarly, these receptors allow the T cell to kill foreign cells or cancerous cells. But then the second acts like the stop pedal or the brake in a car. And so this receptor halts T cell activity. So, however, some cancer cells have learned to hijack this response. So they create molecules that act like the brake receptor and deactivate the T cell, allowing the cancer to spread and grow with little defense from the rest of the immune system and body. So this is where checkpoint inhibitors come in. So checkpoint inhibitors are drugs that are injected in the body and act to block certain T cell receptors and enable the T cell to continue to kill cancerous cells. So this is why they've actually been pretty successful. And so from here on, we have some examples, which David will go into more. We have CTLA-4 and PD-1.
Yeah, so as Kailey just stated, there are two main checkpoints, which would be CTLA-4 and PD-1. So although CTLA-4 is not as successful in clinical trials, it's still important to make a note of. And we can go into more detail at our booth later if you want on that note. And but I'm going to focus more on the PD-1 and PD-L1 binding and interaction, because that is shown to be more successful. And in some cases, there's a drug that inhibits it called nivolumab. And in Hodgkin's lymphoma, a clinical trial said that 87% of the patients actually received some response to it, and the tumor was reducing growth. And So PD-1 actually stands for a programmable death code. So it only is it's only present after an excessive amount of T cell activation. So it's kind of like the T cell's like last response to making sure that the T cell doesn't go overboard and kill too many cells. It is like a death code that kills the T cell when it is overreacting. And so I'm going to guide you through how these work. So here you can see the PD-1 and PD-L1. When cancer cells oftentimes have a lot of PD-L1 present, it's a molecule that is present on the cancer cell, and when that is there, the PD-1 will connect with it, and it will kill the T cell and therefore stop the reaction and allow the cancer cell to keep living and destroying your body. However, nivolumab blocks the PD-1 pathway so that the PD-L1 is unable to bind with it, and the T cell can keep going and keep attacking the cancer cell. And